Hello, everyone. We are Group 25, consisting of Brandon Lim, Sahil Pai, Sahir Khan, and Suresh Tiwari. Today, we're presenting our notes management system for CSE Board 12, Phase 1. So what is our notes management system, you ask? It is a digital notebook designed for capturing and organizing notes efficiently. The key problem it solves is scattered information across multiple platforms. We've all experienced having notes on different apps, sticky notes, and random text files, and our system aims to bring everything together in one centralized place. Let me walk through the core features you see listed here. First, users can create, edit, and manage notes with titles and content, the basic building blocks of any note-taking system. Second, they can organize notes using customizable color-coded tags, which makes categorization visual and intuitive. Third, important notes can be pinned to the top of the list for quick access, while older notes can be archived to hide them from the main view without permanently deleting them. The system also includes search functionality to find notes by keywords across all your content. Finally, the user statistics dashboard that tracks productivity metrics, showing users how many notes they've created, which tags they use most, and helping them understand their note-taking patterns. Now I'll pass it over to Sahil to explain how users interact with these features.
Thanks, Brandon. Now I'll explain how the users actually interact with our system. As you can see on this slide, we've organized the user experience into three main categories. Starting with account management on the left, when users first join, they go through a secure registration with a unique email address. The system ensures no two users can have the same email. Their passwords are hashed using bcrypt before being stored in the database, which is a critical security practice that best protects user credentials even if our database were compromised. The system also includes automatic login tracking, updating the last login date in our user stats table every single time user accesses their account. Moving to the middle column, called Note Management, this is the heart of our application. When users create a note, the system automatically timestamps it with both creation and last modified dates. Users don't really have to think about tracking when they wrote something. They can also edit their notes at any time. The system automatically updates that with the last modified timestamp. Each note has a status that can be set to active, archived, or pinned. Active notes appear in the main dashboard view. Pinned notes always stay at the top of the list, which is perfect for frequently referenced information like ongoing project notes or important reminders. Archived notes are hidden from the main view but preserved in the database so users can clean up their workspace without losing the critical information. Finally, on the right side, we have organization features. The tag system is very flexible, so users can create custom tags, color codes for visual organization. Multiple tags can be applied to a single note, and a single tag can be used across many different notes, enabling sophisticated filtering. So now I'll hand it off to Sahir, who can walk through the database design in detail.
Thank you, Sahil. Now let's dive into our database design, which is the foundation that makes all these features possible. So here on the screen, you can see our complete entity relationship diagram showing all five entities, the user, note tag, and user stats and their relationships. So starting at the top, we have the user entity. You can see it contains user ID as the primary key indicated here with the underline, along with name, email, password, and created at. And notice the one markers next to the user, which indicates the one side of our relationships. So now if we follow this line down from user to note, you can see the one-to-many relationship that user has with note. And so this means that one user can create many notes, but each note belongs to exactly one user. And so the note entity now contains note ID as its primary key, along with title, content, created date, last modified, and status, which is that enum that we mentioned with active, archived, or pinned values, and user ID as the foreign key. And so that foreign key, shown with that underline, is going to create the connection back to the user table and enforce the referential integrity in the database. And now looking at the tag entity, it has tag ID as the primary key, tag name for the tag label, color for that visual customization, and created at to track when tags were created. And so the relationship between note and tag is more complex because it's many to many, as shown by the M markers. And one node can have multiple tags and one tag can apply to multiple nodes. But this is exactly why we have the node tag junction table here. And so the node tag entity has its own primary key, node tag ID, plus foreign keys to both node ID and tag ID. And node tag, there's also a sign date, which also tracks when a specific tag was applied to a specific node. So the thing is that we have a unique constraint on the combination of both node ID and tag ID, which prevents accidentally assigning the same tag to a node twice. So both foreign keys also have cascade delete rules. So if we delete a rule or a tag, all the connections in node tag are going to be immediately cleaned up. So this is to make sure that our database is integrable. And then finally, we have user stats here. And user stats has a one-to-one relationship back to user, shown with those ones on both sides. And the user ID here serves as a primary key and a foreign key. And so there's also total notes and total active tags and last login dates. That's what powers the analytic dashboard that Brandon mentioned earlier. And so what makes this design comprehensive is that we demonstrated the three different relationship types, one-to-many between user and note, and then many-to-many between note and tag, and then one-to-one with user and user stats. So now I'll hand it to Suresh to wrap up with our implementation features.
Thanks to hear. I want to focus on the key implementation features on the right side of this slide. So we're following the MVC architecture model view controller, where we have the model handling data logic and database interactions. We have the view displaying data to users via HTML, CSS, and the controller acting as an intermediary, processing user input and updating the model and view accordingly. Second, we're using parameterized queries to prevent SQL injection attacks for security. We're using cascade delete operations via PostgreSQL, so we automatically remove all associated notes, all tag assignments in the note tag table, and finally all the user stats records. We're also providing real-time updates to user stats every time a note is created, deleted, or tagged. We update the total notes and total active tags columns in our user stats variable. We're also implementing these through database triggers to ensure our dashboard is always updated without refreshes. We also have our backend API enforcing all database constraints like the check, the unique, and the not null constraints, and they're being enforced at both both the application layer in Python and the database layer in PostgreSQL. Overall, I believe our note management system combines solid database design with secure, scalable implementation practices. Thank you for your time, and we're excited to proceed with this in future phases.